So a periodic function, you probably need to start with some definitions here. Actually, today's going to have a lot of definitions, so you're going to be doing a lot of writing today. So a periodic function is a graph that repeats itself at regular intervals. So you need to get your definition down. If you want to write down one or two examples, not all of them, so write down one or two that makes sense to you so that you understand that it's just a graph that repeats itself at regular intervals. So for example, the motion of a yo-yo, the movement of the planets around the sun, the movement of a Ferris wheel, the length of a day. So whichever ones you can think of. Sometimes I think about a clock. A clock could be a good one with your different second, like your minute hands, your hour hands, all of that kind of stuff. And then I've given you 3 examples. So again, you might want to draw 1 or 2 of these examples just to see that this wave just keeps repeating itself. This wave looks a little different. This one is just up and down, but this one kind of goes up and then it goes a little high and then low, but it repeats itself. Like we can look right here and it keeps repeating itself. And then there's one that looks like this, that again keeps repeating itself. Are we good?
Oh,
okay, so here's a whole lot more. So this is a lot of definitions we're getting down. So first one is a periodic function. So it's a function whose graph repeats itself at regular intervals. You will need to learn these words because when we start looking at our sine wave or our cosine wave or our tan wave, I'm going to say things like what's the period? What's the amplitude? All of these kind of things. We're going to write down those words in a second. It is probably sciencey, yes. Science, me neither. We'll make it more fun. Okay, next one is a period. It's the distance or the time, whatever it happens to be, over which the graph completes one cycle. So it can be distance, it can be time, it's however it's measured, so that the graph can complete one cycle. Okay, amplitude. Amplitude is half of the difference between the maximum and the minimum values. So it's also the vertical distance from the function's equation of the axis to the maximum or from the equation of the axis to the minimum. I'm going to go through when we get all these written down and I'm going to show you what I mean. It'll make more sense when we see a wave. But right now we'll just get these definitions down and then we'll see what it actually means on a graph.
okay.
Okay, next one is called trough. It seems like there's no. So trough is the minimum point on the graph, the lowest it goes. We typically say minimum more than we say trough. And then obviously your peak is the maximum point on the graph. And last one is our equation of the axis. Can I move this up a little bit? So this isn't so, is anybody still writing down amplitude? Okay. There. So the equation of the axis is the equation of the horizontal line halfway between the minimum and the maximum. So it's a line just like the equation of the axis, or the, sorry, just like the axis of symmetry, where it divided a parabola in half. This is the same idea, except for instead of it going up and down, it's going to go horizontal, and it's going to divide that wave in half. Okay, so first thing we're going to do is we're going to decide whether it is periodic. What did that mean again, periodic? Repeats itself after regular. Repeats itself. Okay, so does this one repeat itself?
Yes.
Okay, so here's where it starts. Tell me when it ends one period, so one cycle. Tell me when it ends. Tell me to stop. No.
Take a 4.01.
When it reaches like
When it reaches the line.
Yeah, there you
Stop.
go.
And then it's going to do the exact same thing over again?
Yes.
Absolutely. This is one period. And then it's going to take this and it's going to do it again and again and again. Okay? See how it starts here and it's going to go up and then up again, then down and down again. Here it goes up and then down and down again. Good. See that? Okay. Is this so? Yes,
No.
This is periodic. Is this periodic?
No.
No, why not? Look at it, it's going down and up, down and up, down and up. It's not the same. That's right. So this is not periodic. So it could do that, but then over here it has to go back to the same little one again, and it doesn't. So not periodic. So it's not repeating itself. Everybody right now seeing the difference between something that repeats itself periodic and something that doesn't? Okay. Okay, so grab your piece of paper. Actually, no, we're just going to talk about this one. Okay, so the following periodic function highlights one cycle. Or sorry, for the following periodic function, highlight one cycle. When I talk about a cycle, I always try to start at 0. Okay, so if I'm doing it, I would start right here at 0. Tell me to stop when I'm through one cycle.
Stop.
Are we good?
No.
No?
Stop.
So there's one cycle. And then it's ready to repeat itself again and again and again. What is the period? Yes. So in this case, it's not 360 degrees. I started at 0 and I repeated at 4. So my period is 4. Whether that's 4 minutes, 4 seconds, 4 degrees, whatever it is, it's 4. We just write down 4. What is the amplitude? Actually, let's skip amplitude for a second. Let's do equation of the axis. Where is my equation of the axis? Yes, so at y equals -3. So if this is the line right here that divides the parabola in half, now go back and tell me your amplitude. 2. So from here, you went up 2 to get to the highest point. From here, you go down 2 to get to the lowest point. So your amplitude is 2. Remember, if you have done it right, you're going down the same amount as you would go up. Otherwise, your equation of your axis is in the wrong spot. Everybody okay with that?